It gives me great pleasure to be talking about industrial AI, growth opportunities, and what's driving competitive advantages in the industry. I have an esteemed panel of experts coming from different vantage points with respect to industrial AI. And I think this is going to be a fascinating conversation. What I would do is I would briefly introduce each of the experts. I'll let them talk a bit more about themselves. So starting, first person I see on my screen, Ken Foster. Ken Foster is the founding partner of Momenta. It's an industrial impact venture capitalist firm in the digital industrial space. I've known Ken for quite some time now. He is a voice of reason, wisdom, and forward-looking, I would say, approaches in the industry. I've always come out a lot more enlightened every time I speak with him. It gives me great pleasure to have him here. I'll let Ken introduce himself. Over to you, Ken.
Thank you, Karthik. I appreciate the opportunity, the great entry there. It's hard for me to add a whole lot more, so maybe some specifics. As Karthik said, we are a venture capital investor. We primarily invest in European and North American companies in the digital industry space. And that includes heavily in the industrial AI space as well. We have 61 portfolio companies, have had 19 exits, including Edge Impulse that just sold to Qualcomm, and have made a little over 130 investments between those companies. We're backed by some great names like Rockwell Automation, Nippon Steel, Advantech, Semtech, and other companies as well. And so have an opportunity, of course, to always refine our vision and our thesis based on working with these industry leaders. So very excited to be here today and to talk about a topic that is near and dear to our hearts. So back to you, Karthik.
Thank you. Thank you, Ken. Next in line is Thorsten Schroeer from IBM. I've known Thorsten since the Industry 4.0 days. So this is going way back in 2014, 2015. Thorsten has been someone who's been very invested in the digital industrial kind of landscape. It's a great pleasure to have Thorsten join us today. He is the service partner leader of the EMEA business at IBM. He can talk a lot more about what he's doing at IBM. Over to you, Thorsten.
Yeah, hey, good morning, good afternoon, good evening, everybody. Thanks for the invite, first of all, Karthik, much appreciated. Yeah, long time with IBM, working on the AI track for the last 5 to 8 years overall, really. And I think I have a dual position here in this discussion. I mean, on the one side, we are a heavy user of industrial AI in our manufacturing, in our supply chain, but also heavily in a lot of support functions. So I can share some of the experience, the do's, the don'ts, the good, the bad, and the ugly in there, let's be honest. And on the other side, of course, we are a technology provider providing these kind of technologies, which gives a very specific situation that I'm in here. I keep referring to we are drinking our own champagne. It's sometimes it's great champagne, sometimes this champagne still needs some improvement, if you like so. But I'm here to share really some experience and maybe some tips and tricks, what we have done, where we succeeded and where we failed. We are a small group here, I guess, so open to discuss these kind of matters here. Back to you, Karthik.
Thank you, Thorsten. And next is Aniruddha Banerjee. Aniruddha is a co-founder of a firm called Switch On, which is in the field of vision AI. I came to know about Aniruddha a few years back. And so he's pretty much deploying industrial AI in a very novel kind of a way. I think he will talk a lot more as we go into the conversation. I'll just ask Aniruddha to kind of say a few words about what he's doing and yeah, what's his background. Aniruddha, over to you.
Yeah, absolutely. Thank you so much, Karthik, for introducing me. I'm Ani from Switch On. I'm one of the founders at Switch On, look after business development and strategy for Europe and US. I have worked all my life in computer vision and AI, worked previously at NVIDIA, and now at Switch On. What we do is we enable large manufacturing brands reach 0 defects and 0 customer complaints. We are deploying computer vision and AI on the edge for particularly CPG, automotive, electronics, and pharma customers across Europe, also in the Americas and across Southeast Asia. I have seen very interestingly the good, bad, and ugly firsthand in terms of adoption of industrial AI. The promises which sometimes are met and sometimes not read, and also the expectations which sometimes are fair and sometimes are not. So yeah, looking forward to this conversation. Back to you, Karthik.
Thank you, Niruddha. And last but not the least, Boris Schroeer from Siemens. We were almost thinking that we are going to go ahead without you. So Boris is basically the Siemens industrial AI voice. So I have had a chance to speak with Boris on a number of occasions in the past few years. So he always is somebody who has a very strong but a very reasonable view on what industrial AI is. I don't want to give away a lot of what he might possibly want to say during this conversation. So I'll ask Boris to say a few words.
Thank you. Yes, Karthik, and sorry for the last minute join. So I'm part of Siemens Digital Industry CTO office looking into technology trends and also into startup collaboration. I was honored to lead also an internal task force in Siemens Digital Industries on how we use AI internally. And yes, you are right, Karthik, it is a difficult time to navigate between hype and hope, and also to strip down a bit the very high expectations that everyone has on AI coming from the business to consumer world. And then if we are faced with the realities of industry, with the realities of a shop floor which doesn't have an undo button, and with the realities of AI in engineering and all the determinism that engineers wish for, right? We must understand that maturing AI to become industrial grade is still a journey. Yeah, great advances and enthusiasm, but hey, there is a long way to go, and it is as challenging to create and develop and operate an autonomous car as it is to develop autonomous functions, for example, on a shop floor. So thanks for having me.
Thank you, Boris. Very interesting first thoughts. I'll kind of start with an open-ended question. So where do you see industrial AI today? And how do you see it evolving? This is the tough part in the next 2 to 3 years.
So maybe I kick this off because few of us has been maybe 2 or 3 weeks ago at Hanover, the big industrial party of the year, if you like, so once a year. And my observations there was the single most omnipresent topic, industrial AI. Every second booth had a big sign on that. So it is not a new topic per se, but it becomes more and more relevant and apparent to manufacturers, software providers, system integrators. So everybody plays with that. And that even goes now. Meanwhile, I've seen there here and there the new science industry 5.0, which I'm not a strong believer in, to be honest, because when I go back, when we first time saw this industry 4.0 thing, which was like 2009, 2010 or something at Hanover Fair, I don't see most of us really entering the 4.0 stage still there. So too many people, from my perspective, jumping on now on 5.0 on what's next. I think we still have a lot to do to deliver what 4.0 intended to deliver like 6, 7, 8 years ago. I think the industrial AI topic also needs to be looked beyond the pure manufacturing. So also what can manufacturing companies do with their technology in support functions, whether this is finance, HR, IT. So I see a lot of activities there also. And from industrial AI, in terms of what's next, agentic, of course, is the big topic. The question there is, to what extent this agentic thing really gets into the place on the manufacturing floor. I've seen that a lot in our internal supply chain where we applied that. But for sure, everybody is now jumping on the agentic thing, which is the next smaller big wave in there, but still far beyond the industry 4.0 that a few people are talking about. So that's kind of one of the takeaways that I had visiting the Hanover Fair 3 weeks ago.
Interesting.
Perhaps I can go next, probably for 2 reasons. One, I was at Hanover as well. We had 13 of our portfolio companies there between the different mega booths that were there. and actually ran tours for a number of our limited partners and investment banking partners through those companies as well. So one of those companies is an agentic AI company, Composable, former Bonsai team out of Microsoft, and they're actually doing some pretty interesting stuff relative to industrial AI. They literally wrote the book, the O'Reilly book on autonomous AI. So there is some real things happening. Read the book. It is actually a good case study of all of the work that was done at Bonsai and Microsoft in agentic AI. The other reason it's probably good for me to take the microphone here is that I am part of the EU Commission's Industry 5 effort. I've been on the working group for about 3 years now. We've featured their leadership on more than one occasion on our podcasts and other thought leadership. My sense is they say the 5.0 is an evolution, not a revolution. I actually think when you transplant cyber physical efficiencies for a view of human centricity, resilience, and sustainability, that is as dramatic of a change as ESG is to standard business operations, right? And that's really what the commission is trying to push with this. It's a kind of a multi-KPI approach to optimization, which then brings us to why industrial AI is so critical, because it's moving beyond simply, can I run my factory faster or more efficiently? Now I have to think about, can I run it based on the prices of energy today, which in Germany is a really big issue, right, relative to Russian or the lack of Russian gas these days. And can I run it with the labor that I have available today, because labor shortages are everywhere? Can my supply chains change to match my reshoring strategies, right? Today it's China, tomorrow it's Southeast Asia and Japan, and eventually it's truly maybe onshore again, right? To make those kind of decisions and do so with sustainable, resilient, human-centric results requires very complex control, well beyond the traditional or simple AI. The beauty of this space is the PID loop, of which hopefully all our listeners are familiar with, is a form of optimization for process control that started in 1911 with pneumatic controllers, right? So in some sense, we've always been going through some form of industrial control and optimization, whether it's that or the digital equivalent or model-based predictive control, all the way up to fuzzy logic and what we see now. It's been a slow transition that even preceded the term artificial intelligence, that came out in the 1950s. So really, when we think of industrial AI today, we think very much of optimization. But I'm optimizing for a much bigger set of outcomes that I'm looking at. Quality solutions, as has already been mentioned, is a key area that we see as well. And of course, Boris, I'm glad you made the analogy between autonomous driving and autonomous factories, because we think there's very real comparison of those. And so, we learn a lot from the mobility space. In terms of where we see things going, let's go back to NVIDIA, right? Physical AI, which encompasses a lot of different elements, what I'll call edge-centric instead of agentic or edge-entic, if you will, is the idea that I can use agentic AI, but I can do it in a highly distributed fashion, especially kind of framework, if you will, machine learning. And that we see as playing a greater role when you look at the virtualization of a lot of OT systems that is happening. Causal AI, so well beyond root cause analysis, now looking toward real-time optimization. And then generally, we're following a thematic that I think Rockwell has coined called automation to autonomy. We see that as the automation as we know it today, augmentation, right? How do I human-centric operate my factories to support the humans that are there, to truly autonomous or lights-out operations that we think will eventually come there as well. So for us, we're quite excited about this, but this is going back to my Industry 5 example, it's an evolution. It's not a revolution. And very much industrial AI is an evolution, starting in 1911 with the PID controllers and seeing what we're seeing now. So there isn't necessarily big dramatic changes here. It's all incrementalism in some sense.
Very interesting. Aniruddha, Boris?
Yeah, probably I'll go next. I think I'll maybe start a little bit with the state of adoption of things, right? And I do have to agree with both Thorsten and Ken in the sense that I think the adoption cycle of industrial AI is still lagging where I think the innovators are, and there is a huge gap between innovators and early adopters here. And there's an even bigger gap between early adopters and late adopters, of course. What I've generally seen is there are a few, there are a few use cases that are evolving, and most of the adoption is happening on a use case basis rather than a generic, broad-based adoption of industrial AI, right? And a lot of those use cases, for example, some of which we are working on, which is, quality and how to autonomously ensure that you have zero defects, is something that we have been working on and is one of the use cases that we are finding a lot of adoption for. But what we are seeing increasingly is that a lot of this adoption is happening on one particular kind of use case, and these are really vertical applications that are finding more adoption. I think as this evolves, one of the key things that we are seeing is the movement from like point solutions to platforms, again for vertical use cases, right? So there's a lot of move towards, hey, now you're able to do the inspection. Can you autonomously figure out which product to produce in which site and at what manufacturing line under what efficiencies? All right. So really a lot of our customers are looking for solutions where they are looking to automate entire workflows, right? So it's not just about like a one pinpoint inspection need, but it's more about how do I make these lines zero defect? How do I overall scale this solution? And in that, we are seeing a very interesting intersection now starting to happen between pure play software and operational technologies, right? So we do see an interplay where information data is being exchanged nearly real time between ERPs and these kind of edge-based agentic solutions, which is very interesting because in a lot of cases, this leads to gaps where, we suddenly have information we never had access to at a frequency that we would never have otherwise been able to interact with it with. So yeah, this is, I think, the way that we are seeing this adoption evolve.
Now, if you allow, I'd like to add one perspective that is really commercially driven, right? If we look into the business to consumer space, specifically social media, then the effort to really acquire the necessary data for one particular use case is very small. Why? Because the social media platforms have been built as data collectors in the first place. So it's very easy for them to collect, right? The AI's incremental value of a particular use case, let's talk about an ad placement in YouTube or an ad placement on Facebook, right? It's very small. But you scale this above 1 billion Facebook users. So the value pool that you create with 200 data scientists or 2,000 data scientists is huge, right? And this is why so much AI technology has been invented in the B2C space, while the adoption in industry is slow because the use case, value creation, value proportion mechanics is very different. It takes huge effort, or comparably huge effort, to acquire the data. Yeah, every shop floor is different. Semantics is not in place if you haven't put OPC UA in place. And it's really cumbersome, right? The incremental value that your AI is creating, identifying a defect part, a false part, and so on, is okayish. But then how much can you scale? Even if I take an AI model that I have trained here to a different factory in the same company, it turns out I cannot scale it without having another project effort being invested into it to make it happen, right? So the value creation mechanics in the industrial space is different, and this influences a lot how fast the adoption goes. Now, what is a way out? Of course, if we do the same thing like has been done by OpenAI and others, create universal models. create a model that no matter what PCB it looks at, it will identify the soldering parts that are faulty, right? Or the parts that are missing on a PCB. But it must be a universal model, and we cannot work with the, here are 20 good parts and everything else is an anomaly and it's false, because the industrial reality is different. I not only want to understand, can I scrap a false part? I actually would like to understand what is it that I can do to repair it efficiently. So a simple anomaly detection is a good starting point, but it's not sufficiently to really make a difference. So we need to understand what's going on. We need to understand what is the problem with a certain PCB. And only if I create a foundation model for the visual inspection of PCBs, I can offload the project efforts from all the many different companies that are trying to roll out that use case. And that's why I totally agree, right? Vertical use cases, platforms for vertical use cases become popular, particularly if they offer something that is pre-trained and becomes universal, as universal, hopefully one day, as a language model is working with language, right? We would like to see this in the industrial space too, but it's a long way to go.
Well, on the other side, Boris, what our experience is there, we train specific models on specific purposes for our own needs within our own manufacturing. And if you look on the models which are available right now, if everybody uses the same model, where's the differentiation in the marketplace? So I think it is not a question, the bigger the model, the better the impact. So our experience really is custom built models on custom built needs, if you like so. Which requires some training, but that really then differentiates an electronics manufacturing line 1 to an electronics manufacturing line 2 if we really use the right model where you had to put some effort into to train that. I mean, right now, only 1% of global data is searchable from enterprise data, only 1%. 95% of that data probably sits in SAP systems or ERP systems overall. So the question, of course, is how do we attract that? Going back to your social media example, that is easy to access, right? There's no security constraints, blah, 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 blah. But if you then go into planning systems, into ERP systems, in inventory systems, that's a complete different ballgame. And you need to train the machine to deal with these kind of constraints, which is very unique and has some lack of replication in there because not a lot of people are using this stuff. So you need to find not only the right use case, but even the business case associated with that. And that is then all a question about scaling. So that is our experience there, that we try to really work with smaller models that we partly really train to really get the answers that we get and also get the differentiation versus a vanilla model works for everybody in the same area in the PCB space. Different discussion.
I'm with you, Thorsten, specifically when looking at large corporations, and you are certainly one of them. If I look at how can we make industrial AI digestible for small and medium-sized companies, it's a different
Right.
game. First of all, they lack the skill. If they buy the skill commercially, it's going to boost their project costs. And if I have a use case that has a return that saves me 80,000 a year, then it's very difficult to spend 250,000 to do the project to build a small model, right? And that's why for a large portion of the market, we need to achieve a certain universality of large models for industry. So we can save the small and medium-sized enterprises a lot of the project effort that today they have to spend.
I have to jump in here because this is exactly what we are building, right? So I think I have to mention that there are two aspects to this. I think one is obviously from a project point of view. So, just a quick step back, we are building an unsupervised model that automatically can scale and generalize across a wide variety of products, which may be like bottles from CPG to, fuel injectors, et cetera, right? And our vision is to make it DIY, do it yourself. So you can train these models, you can run these models without any changes, right? We've seen two interesting trends here, and I have to highlight both, right? So from a really small scale industry point of view, this makes AI for the first time affordable for them, right? So we've seen, with an approach where this is more do it yourself, you train the models yourself, make it very, very simple, train it within 45 minutes, deploy it quickly. We are able to do end-to-end deployments within 10 days, fits well within their budgets of about 40, 50,000. And makes the ROI viable for them to adopt this, right? So with this, we've been able to unlock really a lot of scaling in medium-sized organizations where there is really an interest to adopt AI, but till now it has been very difficult for them to afford any state-of-the-art models, really. There's another implication which is interesting for enterprises, right? So if you see how enterprise adoption happens, right? So really, even for enterprise adoption to happen, you need centralized budgets and productized deployments, right? So, if, for example, you need to build models as you go from one site to another site, this whole way of deploying any digital solution is very difficult, right? Because, what you want as a large enterprise is to be able to allocate a budget and say that, if I want to deploy it in 3 sites, I'm spending 120,000. If it is 4 sites, it's 160,000 and so on, right? So you need that productization in the pricing. And you also need that productization in the deployment, right? So you need to be able to say that, okay, if I'm deploying in 3 sites, I'll take 30 days. If you deploy in 4 sites, you need 40 days. Because at the end of the day, all of this rolls up into time to value. And unless you're able to be specific around when you're able to realize the value of these solutions, it's really, really difficult for you to drive any of these projects, unless these are really innovation projects. And as you know that, there is a huge gap between an innovation project and a replication project, right? So I think the other way in which I've seen this get adopted as it becomes productized is now, large enterprises are able to budget for these things at a multi-plant, multi-site, level, and budget for that from a CapEx point of view, OpEx point of view, as well as a timeline point of view. And that's basically driven our adoption across large enterprises as well. So now, instead of saying that, okay, I need one model and one vendor for my spark plug product that I make in Southeast Asia, and another model and another vendor for the plugs I make in Germany, you can pretty much say that, okay, I can use the same product and go and scale across multiple geographies, obviously, with their different quality expectations and so forth, right? So this has been, the way in which we've seen a lot of scale across large enterprises as well.
Can I ask? Sorry, go ahead.
Yeah. No, go ahead. I mean, I just had one thought. Maybe I'll just a brief interjection. I think we are talking about foundational models, universality of models and how they could be deployed.
Mm-hmm.
And then, you have the whole idea of distributed edge agentic kind of approaches, which is essentially maybe at the other end of the spectrum. So I was really looking forward to hear what Ken is thinking on this.
No pressure whatsoever. Look, right now, over the last 2 years, there has been a lot of hype around Gen AI, large language models. There's been large corporates that literally, if you're going to get any budget through, it has to have the 3 letters LLM in it, otherwise it won't get funded. Now you're seeing the same type of hype around agentic. From a VC perspective, we love it, right? Because that means these big corporates are acquiring our companies, and our companies are finding hopefully a good place to work with these. The reality is, industrial automation systems have always gone through a transition from decentralization to centralization. You can see it with machine tools. You can see it with traditional DCSs, PLCs, SCADA systems, HMIs, et cetera, et cetera. The end result is these will be highly distributed systems. The challenge is, what are you going to do at the edge, and what are you going to do in a centralized capacity? And by the way, let me throw data sovereignty and cybersecurity, because one of the questions was relative to that, in that as well. So I'm not sure we will see the day that there is going to be some large language model like what OpenAI has relative to our industrial automation space, because I think there are too many barriers to sharing that information. And frankly, I'm not sure it's in the best interest of a lot of the people that would contribute to it at that point. Thus, there's likely to be much more local on-prem models, thus highly distributed models, especially around federated machine learning. And so that's where we're making our bets now. To the degree they can hook to an ERP, an MES, or some kind of a large foundational model, that's great. My reality of having been a control systems engineer for 30 years is it won't happen in my lifetime, right? There's just too many barriers. And now, especially given some of the geopolitical challenges we all have, there's even more barriers being put up all the time. Now, that being said, I think Boris is absolutely right. There's a common learning platform that will absolutely be needed. And to the degree we can share those learnings and apply those, that's great. Right now, most OEMs are providing that relative to their own equipment and preventive maintenance, right? So, machine manuals online, big wow. But when it starts to come to how to manufacture a PC board, or here's best practices that you can share, now that becomes pretty interesting. I think those same small to medium manufacturers are also the ones that are least brand loyal to any large OEM, of industrial automation equipment. So they're going to be looking for heterogeneous solutions, like kind of what's happened with MES these days, right? Very few of it is tied to any one automation stack. It's very horizontal. I have a feeling if we see this kind of optimization, it's going to come at that level. And thus, we're making bets at the extreme edge, just like Edge Impulse is an example, Composable, Luffy, and others. And we are making them in what I'll call the data collection and contextualization stack, because that's how I'm going to get this. I think Thorsten said 90% of data. We think 85% of industrial assets are dark, first of all. So there's no even connect and collect going on there. But those that are producing data and that are connected, most of that data is time series, which just does not lend itself well to a traditional large language model contextualization. Thus, there's a whole layer in the middle. You can look at Litmus in our portfolio, or HighByte, or Aperio. And what we're doing is betting on companies that are effectively turning time series data into real machine readable and thus contextualized data that you can actually do something with at the end of the day. So we see it happening from both perspectives, but I'm much more of a decentralization person than a centralization person. So there you go, Karthik. Hopefully you got what you wanted.
Yeah. Boris was nodding his head sideways, so I want to know what he was thinking.
I tend to disagree. We have tested federated learning quite extensively and also tested a little bit the readiness for the markets to adopt it. And it is a beast, right? Companies are not even mastering machine learning, and then federated learning adds the complexity of distributed system management to it. I love it for its privacy preserving architecture. I think it has potential, but we are very early. We are very early in that regard. Now, once that you go down that cumbersome road of educating companies how to put their data into two buckets, saying this is differentiating IP, and we keep it in our locked, it's our treasure, and this is commodity IP. And if you go into a university bookstore, you can actually buy a book on engineering, chemical process systems, and everything that I can read in a book that I can buy in a bookstore is commodity IP. It's not worth protecting it, right? Then we would have, if companies would do that classification, and we have a couple of partners that are in the process of doing exactly that, then with the commodity IP that you can take and put it into a collaboration partnership, for example, with Siemens as a currency. I pay you with data, you give me DII. Then we see that step by step, these data pools are created specifically in the space of engineering. And so AI, industrial AI gets richer and richer and richer. Also time series data, right? If you knock on the door of someone, say, give me your machine data, they all go berserk. If you say, consider providing me with with some machine data that is aged, 3 years old, right? Nothing younger. We won't be able to read trade secrets out of that data that is 3 years old down the road. They seriously consider it. Some of them do it, some of them don't do it, but then they consider to take this as a currency and help us with creating a time series foundation model, for example, for rotating equipment, right? And as I said, it's not right? It's not detecting an anomaly. I really would like to understand what anomaly is it? Is it a broken bearing or is it some other issue? Because then I know how to act on it. So that's the level of data that we need to achieve. But it's a cumbersome road. I agree on that one with you. That's very clear, Ken.
It's also, again, we're in OT, so it's going to be a very linear adoption. There are no radical changes in OT versus IT.
That's unfortunately, that's very true. Yes, also because the investment cycles, right? If I have a machine in place that doesn't produce data, and my investment cycle is 10 to 15 years before I replace that machine, then right, that's your investment cycle. That's a tough one.
One of my LPs, who I won't mention, I think has a great quote, and that is that people aren't buying us because of our technology advantage or just our technology advantage. They're buying reliability or peace of mind. So they go with my brand because they get the peace of mind of knowing
That
nobody will ever get fired for hiring, in your case, Siemens, right? Or
and
putting Siemens in the
exactly, right?
factory.
That could
Yep.
be, and it's also a value proposition of IBM, and it's also a value proposition of Siemens to really provide that reliability. And that's also the tough part, Aniruddha, for startups, right? If I enter a startup collaboration, super innovative, great algorithms, better than some of the algorithms from the corporates. But if my investment decision is on a production line for the next 10 to 15 years, how can I be sure that the startup partner is still in place in 3 years from now, right? Either it's financed by Ken or it's unsure whether they survive or not.
Well, and more than 90% of our exits are trade sales to companies like yours. So that's just the reality of
Fair
it,
enough.
right?
Yes, fair enough. Of course.
Yeah,
Yeah.
yeah.
Interesting. I'd like to bring Thorsten because I think one of the things, Thorsten, you mentioned to us was initially, you've also been doing a lot outside the traditional kind of manufacturing OT setup. So I would like to understand if there is more potential for industrial AI outside the manufacturing kind of frontier.
Well, still looking at a manufacturing entity per se. So we talk about the manufacturing optimization for the time being. And by the way, there could be another big topic, maybe we can talk on that later, in terms of relocation of manufacturing sites. I mean, I refer to the Tim Cook example where he said he cannot put his Chinese manufacturing platform back to the US, not because there's not the parts or whatsoever, there's simply not enough engineers on the tooling side available in the US. So the question is where AI can really help there, not only on a steady state manufacturing to improve, but also what is the impact in terms of manufacturing footprint. However, based on the question in terms of where are the use cases around AI for manufacturing, I mean, outside the manufacturing side, we see a lot of deployment of projects and activities. On the one side, customer support, customer service, the typical assistant activities, after sales stuff. That is a rather easier use case where manufacturers put a lot of efforts in order to streamline that one. Another big one is HR, where you really use agentic AI kind of activities to resolve HR questions. Like, for example, internally within IBM, we reduced our efforts on HR questions by 95%, deploying an AI, helping me as an individual to answer questions around my HR setup whatsoever. So these are two big areas that we see there. And then if you go towards procurement, that's another big area where we also act like a client zero setup on our side, where we deployed these kind of technologies in order to really drive savings on the procurement process in terms of effort, in terms of men efforts in there. But the common denominator is always we talk about augmenting the human beings in there. So this is not about the classical replacement approach. This is really making an individual more efficient with an assistant AI enablement than without, but not really replacing, because we do not kind of reduce the efforts in terms of labor on our side. We just put the labor that we have, whether this is our manufacturing or HR whatsoever, on those more critical questions where AI cannot really help. So there's a nice saying right now within our organization saying that we might be the last manager generation which managing only humans. we're pretty sure the next generation is going to manage humans and agents. Whether we're going to see that in the next 10 years, maybe. That's a major shift, I think, in there, that going forward, being a manager in a big corporation, you need to know how to manage human beings, but also you need to manage agents in order to drive efficiency. So this is how we look at that and how we deploy that also internally to drive efficiencies, drive savings, and make good use out of this technology with all the limitations we haven't talked on yet, that in terms of governance, in terms of security. And this is all still out there, not partly resolved, but not maybe end to end. But there's still a long way to go around there. But we really look at that, coming back to the question, deploying that really on the supply chain, planning, manufacturing side. That's the typical thing that we talked about. But all these support functions are also very good candidates to drive efficiency, to make a company running faster, smoother, more productivity. And again, automation is the other big topic associated with that. So this is how we look at that.
Interesting. One, I would say, major pain point we currently see in the industry, which all of you might also be aware, is the rapidly declining workforce, or the dearth of skilled labor, which is pretty much, a major pain point. A big, I would say, stifler for expansion, innovation, and greater investments in manufacturing, especially in the developed markets. Can industrial AI actually help address this?
If I may start answering that question, Kartik, at a certain point in time, yes, right? Today we have, of course, automation. Automation helps, right? A robot taking heavy loads takes heavy loads off of a person that may be elderly age, for example. Yeah, so certain tasks become easier. That's one way to look at it. Industrial co-pilots can support workers and help junior workers to level up quickly with senior experience stuff on the shop floor. I see too much stuff being dependent on humans in the loop. So if hallucinating models produce output that always requires the human in the loop, worst case, even the expert to review. Yeah, that's a specific side comment on agentic AI. If I have so much agentic AI that produces output that then needs to be reviewed by a human in the loop, in the loop, I can't get rid of the experts, which ultimately is what I want to do. I want to reduce the dependency on the experts, because we see this decade of people retiring, experts retiring, specifically in parts of Europe and in Germany and in Italy, and where the machine tool builders of this world are, for example. And to really build systems that include sufficiently stringent quality management. So I don't accept a certain solution proposed by an agentic AI prior to it being simulated by a simulation agent that uses traditional solvers, non-AI solvers, to really fireproof the solution that is proposed to me before I present it to the human. Before we are getting some level of quality management stringently, industrial grade quality management into the system, I think we are overpromising on the skill effect that it has.
Interesting. Any other points?
Yeah, maybe I'll go in, because this is something, again, that's an interesting trend we are seeing. So I think, one of the key things that a lot of product companies, industrial AI product companies, are starting to do is they're starting to encapsulate a lot of the expert knowledge in agentic AI systems, right? And making them as easy to use as possible, right? I think overall, the idea is really very simple. I mean, you really at some point in time will not have these experts around, right? And also bear in mind that, finding skilled workers to work in manufacturing itself has become a huge challenge, due to the opportunities that other industries generally provide. All right. And so there is a trend towards making, I think, simpler products where a lot of the actual expertise lies inside the AI system, right? We've also seen very interesting cases where there is a combination of AI and non-AI algorithms. So, a combination of AI algorithms and rule-based algorithms, to some extent, they provide a kind of a maker-checker, mechanism where, while, one system, and it can be either of the two, by the way, one system makes a certain promise and the other system validates whether that promise aligns to the reality, right? And that's really, a lot of the ways in which the modern AI, industrial AI systems are being architected. And you really don't have any other option but to do this because, one of the other interesting things that industrial AI requires is it requires a certain level of reliability and precision that AI systems are generally not designed to provide, right? Recommended systems are not supposed to be 99.9% accurate, right? But if you really ask any quality team in the shop floor, 99.9% is probably where they start, right? And so so it becomes very important to design these systems having the end user in mind. And so, what we have done in our product as well is to have a combination of rule-based and AI systems, where they can individually create and check transactions to ensure the quality standards are met, in a way that this system becomes valuable and useful to our end customers.
And
Boris made
one
the analogy earlier of automated driving and to industries that I like. If you're familiar with the 6 stages of autonomous driving, right, the 6-level model, the first 3 stages are where the human is in control and the machine, the car, is assisting them progressively more at each stage, and then right at the middle, the machine takes over control and the human observes or oversees, ultimately to the point where you have fully autonomous driving. We apply the same thing toward any AI use cases we've got in terms of industrial automation and areas like that. And so our thesis for the next fund that we're working on now is literally level 3+, right? And so the machine is in control, but it assists the human, and the human is going to progressively be moved, if you will, to the point where they're overseeing or approving, the machine's actions all the way to the point. So it's not I'm not doing AI and tomorrow I'm doing full AI and it's going to replace the humans. There is a general trend, a transition, if you will, that we see. And arguably, with, again, model-based predictive control, PID, et cetera, we are already probably sitting at kind of level 2, if you will, from an industrial automation perspective. We have loops that are automatically controlling the voltage in your home right now, or in your commercial, controlling the frequency, controlling the water pressure, everything else. And there's no humans in the loop doing that. It's all set points, right? Humans set the set points and the machines maintain the set points. We see the same thing happening relative to the use of industrial AI, and it's literally a question of at what point does it set the set point itself automatically, and then transition to that. And so we talk a lot when we look at potential companies, how many of them are closing the loop. That means they're so well trusted by whatever process they're running that the humans are willing to step back and let them control the loop. We're seeing a lot more of this, even a recent one that is in Germany, and they've gone so far as to get the Works Council, if you're familiar with kind of German employment law, to approve literally taking all operators and training them to be maintenance people, because they feel like the operator of the future is literally, it's going to be lights out, and everybody comes maintenance workers and basically tunes the machines and repairs them in the off shifts, right? So we're seeing a lot more of this, but it's always going to be this gentle transition that's building up trust, the same way as any form of automation that's been there.
And don't misinterpret me in a sense that I'm saying there is a journey still ahead of us, right? We have use cases, we have single implementations, we have great solutions from startups, we have good starting points, but I still believe we are, on the first mile of a 10-mile journey, as opposed to the promises of generative AI taking over the world and running the show for us. So my point is, it's an ecosystem journey ahead of us. Yeah.
Yeah. And do you foresee a situation where we could have like model wars, like like what we have in the B2C space, in the B2B space?
Maybe not model wars per se, but there is going to be a competitive situation. Who is the smarter entity to apply this kind of technology, right? And at the end of the day, the different technology providers, they're probably not a big difference in term provider 1, 2, or 3. My software product, people are going to kill me for that. But at the end of the day, it's more a question: who is the smartest entity to apply these kind of technologies? So the model itself, there might be differences in a percentage way, maybe. But what is the smarter, faster organization to apply those? And the topic that we have not looked on right now is how do we make the employees part of that? Because to me, this is not going to stay a topic owned by data scientists and somebody in the back office to come up with great solutions how to better manufacture a piece of PCB board whatsoever. So what we have done in our manufacturing setups, really, we made our senior manufacturing engineers, getting them to the data scientist domain, if you like so, in order to apply these technologies in their environment. Because at the end of the day, you cannot make a data scientist a great manufacturing engineer, but you can make a manufacturing engineer give that tooling to make them a better use of this kind of technology. So one of the big trends that we are seeing is really make that technology easy enough, good enough, to be handled by people who are the domain owners and not being the data scientists owners. And we all keep very strong and proud about our domain knowledge here in Germany in terms of manufacturing. That is the asset we have in order to run efficient manufacturing. But if you give those kind of domain owners access to these kind of tooling, I think that is the way to the future. Whether this is model A or 2, B or 3, maybe there might be certain differences, but at the end of the day, giving that tool to somebody who knows this domain is the killing argument from my perspective.
Yeah, we at Siemens define industrial grade AI as being robust, as being accessible, which exactly matches your point, and as being with a purpose. So it's not a sandbox play environment. It really makes a difference in resource efficiency and for sustainability. Adding to that thought, just one comment: we are very shop floor focused now, and we are a bit neglecting the power that AI can have in the space of product design. And let me just reiterate that thought to you: 80% of the sustainability footprint of a product are defined in its design. And I think sometimes we look in industry a little bit too much onto the robots of this world and not enough to, design space exploration, AI in engineering, material discovery and all of that stuff that we really must leverage to address one of the biggest challenge of mankind, which is climate change. Yeah. So let's not forget that discipline. It would be probably worth an own webinar and an own panel discussion. But shop floor is great. Product design is even more important.
Yeah, well said, especially when you start talking about round trip or circular, round trip engineering or circular economies, right? They're very much tied together.
Yeah. Very good. I think you had anything to say, Aniruddha, on this?
Yeah, I think the only thing I would like to add is on this particular model war topics. I think, I think it's becoming very, very clear that different model houses are developing their own expertise around different use cases, right? And so I think this is my opinion is that this is going to show up even more in industrial AI, right? Because a lot of the vertical applications and use cases that are being built, AI agents, AI models are being trained to solve these particular applications, right? And so imagining one company being able to have all of the expertise, have all of the the generalization to handle anything from product design, engineering, manufacturing, inspection, supply chain optimization, I think it's going to be a huge topic. The way I see this evolving is there is going to be an ecosystem of companies that have specific expertise in doing certain things, and people and system integrators and people are going to find a way to stitch these solutions together to ensure that end customers get the most value from this. This is, by the way, exactly how industrials have been for decades now. I'm sure, we all know that there's like 5 bottling companies that everyone around the globe uses, 4 capping companies that everyone around the world uses, and so on. So I see the model companies and the AI providers being very similar, where there'll be specific expertise around either manufacturing processes or end products, right? And they are going to be plugged into a broad ecosystem where different companies develop different models to optimize different processes.
Yep. Thank you. I mean, I think the whole model conversation can be another panel discussion in itself. I think this is going to be the next frontier for industrial competition. At least that's how we see it. I really have to now give it back to Julieta. We have a poll question and then we have a couple of questions. Julieta, back to you.
Thank you, Kartik. We'll now launch a quick poll question to get your input on where you are in your transformation journey. Please take a moment to select the option that best reflects your current stage. Can Frost & Sullivan be your transformation partner? You can talk to our experts to dive deeper into transformational strategies and explore specific needs within your company. You can join Frost & Sullivan's Growth Council and gain access to growth webinars focused on transformational growth strategies. You can designate your company as a company to action to increase exposure to investors, new M&A opportunities, and other growth prospects for your business. Or finally, you can become a Frost growth expert in your area of specialty and share your expertise and passion with the community through our growth webinars. So I will leave this poll open for a couple of minutes so that everyone can vote. And once the growth webinar concludes, Frost & Sullivan team will connect with you to discuss your responses. Back to you, Kartik. Thank you.
Thank you, Julieta. So, no, fascinating conversation. I think there are a couple of questions, but we are really running short of time, as I would expect maybe a brief kind of response from each one of you. I think the first question that we had was from LinkedIn Live. How is the sentiment of manufacturing companies with respect to data privacy and cybersecurity? And how open are industries? And while Industry 4.2 has not seen complete adoption yet, how do you see AI adoption going forward?
It's difficult. And I told you the story about commodity IP, differentiating IP, and there are very few companies that really have gone through that exercise. But opening up is needed. Otherwise, we cannot create industrial AI without data. The promises of synthetic data are great, but we still need to have real data as a starting base. Survival is not mandatory, so everyone can stay a closed shop. I just don't know how long that will, how long it will take until people lose competitive advantage by staying closed.
Ken, Thorsten, Aniruddha?
Not a lot more to add. I think we discussed this a little bit earlier, so please, guys, sorry.
Well, the topic that I come to my mind is Catena-X, right? This has been one of the big challenges here in the European marketplace, at least, to address openness, trustfulness, again, AI governance, responsible AI, a lot of different topics around that. I still grew up, like even maybe 5-6 years ago, where the head of manufacturing says, my data never leaves my premise, my manufacturing hall. Well, here and there, we moved away from that, but I still feel there's still a lot of manufacturing leaders thinking that way. And that then drives, of course, solution that Anurag refers to in terms of edge solutions. How can you run these kind of technologies in a on-prem environment, whether edge or really within your facility? So this, my data does not leave my premises, is still something that I hear for those owners, going back to Boris' topic on terms of IP. Because if that IP leaves my manufacturing kind of premises, I really get in trouble. So it is a topic, it is an issue being worked on, but from my perspective, Catena-X, going back to that one, addressed that. but I don't think that we succeeded there as the initial kind of expectation has been, even 2 years before, where this was then Gaia X, right? So that shows how complex that is, and even a lot of companies joining forces to address that. The outcome is not there where we need to have it. So that's probably still something the next generation needs to address.
Okay. I think we have a couple of more questions, but I'm just being conscious of time. Thank you very much for this conversation. This has been a very delightful and very profoundly insightful conversation for me. I think we are really moving ahead when it comes to the topic of industrial AI. I mean, the kind of points that all of you raised, I think this kind of indicates where we are in the current industrial AI journey. I think I already have my own ideas for the next panel, and I will certainly try to invite all of you again. Thank you very much, and I wish you all a very good rest of the day or a very good evening. Yeah, goodbye and take care.